Hello. In this video, we're going to continue learning about the unit circle, and in particular, we're going to use the unit circle to solve some trig questions. Now to start, we need to just review the unit circle. So here we have the full unit circle written out. Remember, we have our typical numbers in degrees, 0, 30, 45, 60, 90, and of course in radians as well, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Then we take those numbers and we just extend them into the other quadrants. And similarly with the main points, we have this point 1 and 0, which again I think is pretty easy to see. The x value is the first one, the y value is the second. It's like a coordinate point. We can see that this point right here is 1 on the x-axis because the unit circle has a radius of 1. And it's 0 on the y-axis because it hasn't moved up at all. Then as we go through the points, we have root 3 over 2 and 1/2. Then we have root 2 over 2 and root 2 over 2. This is the one that's the same on both the x and y. Then we flip them around, so we have 1/2 root 3 over 2. And when we get to the very top, we have 0 and 1. Then we just take these 4 points and we mirror them over here, and over here. So if you know it in quadrant 1, you really know it in all the quadrants. You just have to determine whether the signs are positive or negative. Now, there's an easy way to do that. Remember that the x and the y on the unit circle correspond to cos of the angle and sine of the angle. That's helpful for two reasons. First off, it's helpful because we're going to need to use the unit circle to evaluate cos and sine. But additionally, we can use our cast rule and just some logic to help figure out which sign is which. So we know that in quadrant 1, all should be positive. In other words, both sine and cos are going to be positive, which we see. In quadrant 2 over here, only sine is positive. That means only the y values should be positive, so the x values are negative. Down here, tan is positive, which means sine and cos are both not positive. In other words, negative, which we can see here. And in the last quadrant, only cos is positive, which means we can see the sine or the y values are negative. Alternatively, you can think about them like actual points. Right over here in this quadrant, we've moved left on the x-axis. That's why the x values are negative. Down here in this quadrant, we've moved left and down, making both x and y negative. Over here, we've moved right and down, so the x is now positive, but the y is negative. All right, so let's use the unit circle to find some values. We could, for example, determine cos of 210. The idea here is that, yes, if you had a calculator, you could type in cos of 210 and get an answer, but how would you find this value without a calculator? Well, you'd use the unit circle. You would go over to 210, so you'd look on your unit circle, there's 210. This is going to be our point that we use, and we ask ourselves, cos, is that going to be x or y? That's going to be the x coordinate, which means the x coordinate is negative root 3 over 2. So negative root 3 over 2, and we box our answer. Now again, if you have the Mr. Peters approved calculator, you can type this in and take a look. And if you do, you'll find, of course, that cos of 110, assuming you're set to degree mode, right? Make sure your calculator is set in degrees. You should get an exact value of negative root 3 over 2. Okay, so let's step it up a bit. How would we find sine of negative 945? If you look at the unit circle, that angle isn't exactly on here. I mean, first off, the only angles we have are positive, and second off, the biggest we get to is 330. How are we ever going to find 945? Pause the video and see if you can come up with some ideas. All right, the basic idea here is that if you were asked to find, let's do something easier. Let's say we were asked to find sine of 300 and, let's do 390. 390 isn't on the unit circle. But if you were to draw the angle 390, what it means is it's sort of like 360 and then 30. That's how you can think about 390, right? We would subtract off a 360 and we'd be left with the 30, which is the principal angle. So really, it's like a full revolution and then to the 30. Okay. Well, what is sine of 30? Sine is the y value, so it's going to be 1/2. In other words, what we do is we take our angle and we find the principal angle, and then we just look for the principal angle on that unit circle. So it's negative 945. Obviously, we're going to have to add groups of 360. One 360 won't be enough. Two 360s won't be enough. I think we're going to have to add three 360s. If we do that, we're going to get 135 degrees. So now we look over to, let me do this in another color. 135 degrees is right here. That means we're going to look at this value, and we're going to grab the y value for sine. And that means our answer is going to be root 2 over 2. All right, let's try another one. Here we need to find tan of 1,485. So again, I'd encourage you to pause the video and at least try to find that principal angle. All right, assuming you paused the video and gave it a try, we're going to go ahead and subtract groups of 360. So one 360 probably won't be enough. Two 360s. Let's try three 360s. That's going to give me 405, which is still not quite enough. So we need one more 360, and that's going to give us 45 degrees. So my principal angle is 45, and so I need to find tan of 45. Now, tan doesn't have a specific coordinate on the unit circle. What we need to remember is that tan, this is really important, tan theta is the same as sine theta divided by cos theta. In other words, if we want to find tan of some angle, another way to approach it is to find sine of that angle and divide it by cos of that angle. Now remember, on the unit circle, the coordinate is cos sine. So we need to take the y value of the coordinate and divide it by the x value of the coordinate. So if this is our coordinate right here at 45, we need to take the y value, root 2 over 2, and divide it by the x value, root 2 over 2. Now, thankfully, this is a pretty easy division question because the same number divided by the same number, even if it's like a crazy number with radicals, is just going to be 1. And so the answer to tan of 1,485 degrees is 1. Now, I just want to dig in a little bit more here to tan to make sure we're comfortable calculating tan of different angles. So we're going to do tan of 0, 30, 45, 60, and 90. Again, what we do here is we simply just take the coordinates and divide them. So for tan of 0 degrees, we would take this coordinate right here. So 0 divided by 1, which is 0. Now pause the video and see if you can try the other ones. Okay, let's try tan of 30. This is going to be 1/2 divided by root 3 over 2. The fraction works a little tricky. We can write it as 1/2. Division means we flip and multiply. So you get 2 over root 3. The 2's cancel. This gives you 1 over root 3. Or if you rationalize, you get root 3 over 3. So either 1 over root 3, if you want to leave it unrationalized, or root 3 over 3. But those are acceptable answers for tan of 30. Let's go ahead and do tan of 45. This is the one we just did, root 2 over 2 divided by root 2 over 2, which is just 1. Let's do tan of 60. This is root 3 over 2 divided by 1/2. Again, the fraction works a little tricky. We flip and multiply that second fraction, cancel the 2's, and just get a root 3. Finally, the last one, tan of 90. That's going to be 1 over 0, which is, oh, we can't do that. That is undefined. If you try in a calculator to type in tan of 60, you'll get an error. And so tan of 60 actually doesn't work. So if that was ever a question, you write undefined. But the other ones all work out fine there. These are the nice values for tan. And of course, if you need to do them in other quadrants, it's going to be the same basic number. You'll either get a 0, 1 over root 3, a 1, a root 3, or an undefined, and then you just might have a negative sign in front of it. All right, let's try this question, but in radians. So we have sine of negative 17 pi over 4. Again, if you look at those radian measures, none of them are 17 pi over 4, and certainly none of them are negative. So you're going to need to find the principal angle. Pause the video and give it a try. All right, so we need to add groups of 2 pi. Now, this is tricky again because we have the fractions. So let's write it as 8 pi over 4, because 2 pi is the same as 8 pi over 4. And 8 plus 17, that's not going to become positive yet. So we're probably going to need to add another 2 pi. 2 8s will be 16, but positive 16 with that negative 17 still won't be positive. So let's add one more group of 2 pi. All right, 8, 16, 24. So this is negative 17 pi plus 24 pi over 4. That's going to give me 8, 16, 24, take away 17, 7 pi over 4. If you notice, that's right here. So we found the principal angle. The principal angle is on the unit circle. All that's left to do is notice that sign means we're looking for that y value. The y value is right here. So our final answer is negative root 2 over 2. Go ahead and box it up. Okay, let's do a really fun one. We have cos of 2023 pi over 2. Now this one, it's pretty large. You're going to have to subtract a lot of groups of 2 pi. You might have to be a little bit clever with how you do it, but go ahead and pause the video and give it a try. Okay, so we have 2023 pi over 2. We're going to be subtracting groups of 2 pi, which means 4 pi over 2. Now, we need to subtract more than that, and so you could multiply this by, let's say, 100. Because if you multiplied it by 100, you'd be just subtracting 100 groups of 2 pi. That would be 400, but that probably wouldn't be enough to get to 2,000. So maybe not 100. Maybe we should multiply by 1,000. That might be too much. Maybe 500. 4 times 500. Well, that's going to be 2,000. Okay, let's start with that. So we have 2023 pi minus 2,000 pi over 2. Again, the pi's just go along for the ride, and so we have 23 pi over 2. Okay, we probably need to subtract some more 2 pi's here. So let's subtract another 4 pi over 2 times, maybe times by 5 again, because that'll be 20 pi's. That seems pretty good. So 5 groups of that. 23 pi over 2 minus 20 pi. It's going to be 3 pi over 2. Hey, look at that. We finally got a principal angle. Now we're looking for cos. Cos, of course, means the x value. The x value is 0, so the answer to this whole thing is just 0. Okay, we got a big one here, and this time it's tan. So go ahead and pause the video, find that principal angle, and see what you come up with. Okay, so 53 pi over 6. Again, I'm going to need to be subtracting 2 pi, which means I'm subtracting 12 pi over 6 if I common denominator. That's not going to be quite enough. Maybe if I subtract 2, 3, 4. Well, I know if I subtract 5 times 12 is going to be 60. That's too much. So let's subtract 4. See what that gives me. Again, it's a bit of trial and error here. You can't really go wrong, because if you subtract too much, just go back and subtract 1 less. If you don't subtract enough, you can just keep subtracting. 53 minus 48 will be 5. 5 pi over 6. That's right here. We're looking for tan. That means we need to do y over x. So we're going to need to calculate, maybe I'll do this down here. We're going to need to calculate 1/2 divided by negative root 3 over 2. Now again, the best way to do this is to flip and multiply. So 2 over negative root 3. Oh, let me put that negative a little better. 2 over negative root 3. Cancel the 2's. 1 over negative root 3. And we don't have to rationalize, so this is our answer, negative 1 over root 3. Now, sometimes you'll have questions that ask you to do multiple trig values and then do some arithmetic with them. In this case, we're asked to find sine of pi over 3, and then find cos of pi over 6, and then add those two numbers. Now this one's relatively straightforward because both of these are on the unit circle. If we're looking for pi over 3 and we're looking for sine, which is y, we'd have root 3 over 2. If we're looking for pi over 6, that's right here, and cos is right there. Now we simply use our arithmetic skills, so this will be root 3 plus root 3 is 2 root 3 over 2, and the 2's cancel, giving us root 3 as our final answer. Or we could put equals root 3 up here. So again, step 1 here, if you think about it, is find the actual trig values, and then step 2 is combine them using our basic skills of arithmetic. Of course, the arithmetic might be a little more complicated. Here we have cos of pi over 4 and sine of pi over 3, and we're going to divide the values. So let's get started. We're looking at pi over 4. Cos means x, so we get root 2 over 2. Sine of pi over 3, that means y. So we've got root 3 over 2. All right, let's go ahead and crunch those. Root 2 over 2, flip and multiply, 2 over root 3. The 2's cancel, so root 2 over root 3. Now you could definitely leave your answer like that, but there are a few ways to simplify this. One alternate form would be to put the whole thing under a root. So root of 2 over 3. Another thing you could do would be to rationalize that denominator. So you get root 2 times root 3 over 3. And you could combine those roots to be root 6 over 3. So all of these are equivalent answers. And I just want you to be aware of that in case your worksheet or your calculator gives you something that doesn't look like what you have. Chances are you're probably right, and you just have it in a different form. But all three of these would get full marks on the exam. So they're all good. Whichever one you're most comfortable with, just go ahead and do that. All right, here's a really fun one. We need to find sine of 5 pi over 6 and then square it. Then find cos of 5 pi over 6 and then square it. And then BEDMAS says the last thing we'll do is the addition. So please pause the video and see how far you can get. All right, so assuming you gave that a try, 5 pi over 6 is right here. First we have to find sine, which is 1/2. That's going to be this one. Then we have to find cos, which is going to be negative root 3 over 2. Now again, we have to do the squaring first. So 1/2 squared is going to be 1 times 1 is 1, 2 times 2 is 4. Here, the negative makes a positive, and root 3 times root 3 is just a 3. 2 times 2 is 4. Finally, we add them, 1 plus 3 over 4, which gives us 4 over 4, which gives us 1. Okay, so the final answer here is just 1. Let's go ahead and take some notes on this. This, we could say, is evaluating trig expressions. And of course, this is with no calculator. And the basic steps are to find principal angle, and then use the unit circle, and then finally simplify in case there's any arithmetic you have to do at the very end. So here's a nice example. We have cos of negative 5 pi over 6, sine of negative 5 pi over 6, and sine of 17 pi over 3. So you have to find each one of those as a principal angle. So this one, and this one. Then we need to find them all in the unit circle, and then we need to simplify the whole thing. So please pause the video and give it a try. All right, assuming you gave that a try, we should have the following principal angles. So here we're going to add 2 pi. That's going to give you 7 pi over 6. This is also going to give 7 pi over 6. And this one is going to give 5 pi over 3. Now for each one of these, we need to look up our unit circle. So for the first one here on cos, at 7 pi over 6, we're going to have negative 1/2. Oh, sorry, that's the sign. At cos, we're going to have negative root 3 over 2. For sine, we're going to have negative 1/2. And then at the 5 pi over 3, for sine, we're going to have negative root 3 over 3. Negative root 3 over 2. Now, again, we could work on the whole thing by flipping and multiplying all the fractions, but we can notice here a little shortcut. These are both the same, so they're going to cancel. But if you don't want to do that, I will show you all the steps. So we take this first one and we write it as negative root 3 over 2 times 2 over negative 1. And here we flip and multiply. We don't need to worry about the 1 there, so this just becomes 2 over negative root 3. So this cancels with this cancels with this. And so that's going to leave us with 2 over negative 1, which is just negative 2. So that whole complex expression just evaluates to negative 2. Now, what I would encourage you to do, even before you try the homework, is go ahead and write out the unit circle again. If you noticed, solving these questions is really fundamental. Using the unit circle is just the most important part, really, of the steps. And I had the unit circle on each one of our slides so we could refer to it. But on a test or on the exam, you won't have a completed unit circle. Now, you can create one yourself, and that's what I would encourage you to do. On the test and on the exam, you're given a blank unit circle, and you can fill that in. But you definitely need that unit circle handy. And so because you're not given a filled-in unit circle, you need to be able to create your own so you can use it as a reference. Now, if you really don't want to do this, you're welcome to just memorize all the trig values and get really quick with them. And for some students, that's definitely doable. But it's just nice to have that backup, to have that unit circle handy. And so I would encourage you to take that unit circle and just copy it out. Write out the unit circle. This might be the second, third, fourth time you've written out the unit circle. I would encourage you to just keep doing it. Taking a unit circle and writing it out helps get those values in your brain, and of course helps get you comfortable creating your own unit circle so you can use it as a reference on the test or on the exam. After that, you can go ahead and try Unit 5, Worksheet 6, and then write down any things to remember. One thing I might write down is that tan theta is equal to sine theta over cos theta. We need that when we're doing the tan values. And of course that the x and y values on the unit circle, they correspond with cos of the angle and sine of the angle. So x is cos and y is sine. All right, hopefully you enjoyed that video. And as always, thanks for watching.